Switches found on home networks or very small networks tend to be very simple devices which, once plugged in, begin forwarding frames according to their MAC addresses without any configuration needed. This type of switch is referred to as an unmanaged switch. Enterprise level switches are much more complex devices which offer a broad range of configuration, maintenance and troubleshooting features. This type of switch is referred to as a managed switch. CISCO CATALYST switches are a family of managed enterprise level switches, and this section is designed to provide an introduction to the features and the operating systems of these products. CISCO switches and routers run a CLI based OS called INTERNETWORK OPERATIng SYSTEMs. Although the IOS commands will vary depending on the function of the device in question, the basics of OS remain the same, and so a fundamental knowledge of using CISCO IOS is a very useful skill for any network technician. IOS provide the foundation for many of the CISCO network certifications. We will also introduce Packet Tracer, which is a free network simulator provided by CISCO, which allows you to build and test some advanced network in a virtual environment. There are three popular methods of accessing the IOS on a CLI. These are a console connection. This is a direct serial connection to the device which does not require the network to be functioning. This is particularly useful for the initial setup. CLI access via Telnet. This requires an IP address to be assigned to the device and so does require the network to be functioning. Useful for maintenance. CLI access via SSH. Again requires an IP address and a functioning network. As SSH solves security issues associated with Telnet, this would be the preferred method of remote administration. As we are about to set up the switch for the first time, we will assume that we will be connecting via a console cable. This is commonly referred to as a rollover cable. Traditionally, this was a connection between the console port and a RJ45 plug. The other end was connected to a 9-pin serial port of the PC or laptop. As many modern computers do not provide a serial port, it is common to see a USB adapter in use, or a cable wired directly to the USB. To access the console, you would connect using a terminal application such as Hyperlink, older versions of Windows, or PuTTY. Although second-hand CISCO equipment can be purchased quite cheaply and you can set up your own lab, CISCO themselves provide an advanced network simulated package called Packet Tracer. This is useful for those who are currently at the training stage and also to experienced professionals who are able to simulate and test advanced networking configurations spanning multiple cities, all from within a simulated environment. Using this software package also saves money and space as labs become more advanced and demand more equipment. If you are interested in finding your own physical equipment, your tutor can help, but suggested you complete the initial stage with the Packet Tracer software. To download and use Packet Tracer, you must first create a free account with the CISCO Learning Academy. This also includes a free introduction course to the software. It is recommended you take the course, but it is not essential to continue with this task which follows. You can sign up here. An email will be sent to your inbox. Just follow the instructions that will guide you through the installation process. After the installation is complete, an icon will be placed on the desktop. Once you click on this, you will need to log in again to your account. In this Packet Tracer lab, we are going to be introduced to some of the iOS features and commands. The first device we shall be using is called a CISCO 2960 switch. We can see here that the screen is split into several toolbars. The first of these can be found in the left hand corner, and this is where we can find our devices, cables and network devices. We can move the mouse over the icon found here and we are presented with different descriptions: network devices, end devices, components, etc. If we click on the second icon from the left called End Devices, we can see that the icons in the bottom area have changed, and so have those found on the right. Rather than look how each of these icons work, we shall just jump in and work through them as we create our first network. To select a switch, we must first click on the icon called Network Devices. If we then hover the mouse pointer over the first icon found below, we can see the description, Routers. To the right, we have a selection of 13 different routers. If we now hover the mouse pointer over the next icon in the lower toolbar, we can see the description, Switches. By clicking on this will cause the icons on the right to change. We can see 8 different switches. The numbers refer to the model of the switches. This part of the window is called the Workspace, and here is where we can construct our networks. There are different ways of adding devices to the workspace. In our example, we shall drag the icon onto it. So we place the mouse pointer on our selected device. Here it is the 2960 switch. Holding down the mouse button and dragging the icon into the workspace, we can see here a description 2960-24TT switch 0. This is a model number 2960 switch with 24 ports, and it has been allocated a name called switch 0. Here we can see the specification of the switch. If we scroll down the page, we shall find a more detailed description of the ports themselves. We find that number 1 represents a total of 24 of 10 100 megabits per second Ethernet ports, and number 2 represents 2 of 10 100 1000 megabits per second uplink ports used to connect to other switches. Back in the packet tracer, hover the mouse cursor over the switch and you will see that the ports are listed. This matches the description perfectly: 24 fast Ethernet ports and 2 gigabit Ethernets, the uplink ports. We can also see many other useful details, such as the VLAN each interface belongs to, logical grouping of virtual networks. This may not seem to make any sense right now, but later we shall discover what virtual networks are. Whether the interface is up or down. In other words, we can switch a port on or off. This is useful, preventing unauthorized persons plugging in a cable to join a restricted network. If any IP addresses have been assigned to the port, this means the switch can be individually programmed with unique IP addresses. One switch can serve many networks, even if they are on different subnet masks. The MAC address associated with each port, which is important for devices that rely on MAC addresses. The hostname of the switch itself. Obviously, this is a useful feature of Packet Tracer, which we would not be able to do with a physical switch. However, in the coming tasks, we will discover how to find out this information from the CLI and also how to change these settings. If we take a look at the reverse side of the switch, we find a port labelled console. Here we can connect a rollover cable and then the other end to a PC or laptop from which we can start the configuration. So first we have to select the end device. Here we can see that the second icon represents the end devices. If we click on this, we can see a selection of end devices. Hovering the mouse over each icon, we can get a description of the devices that are available. We shall drag the genetic laptop onto the workspace. These two devices require connecting together. Hovering the mouse over the fourth icon reveals that this icon is used for the connection, so we click on this. Once again, hovering the mouse over each of these will give us a description of each connection. In our example, we need to select a rollover cable or console cable. Clicking on this, first the icon changes, and when we move the mouse onto the workspace, we can see the mouse pointer has changed also. Then click on the switch. So here we can connect the cable to the port. In our example, we shall connect to the console port. We can see how we can move the cable in any direction. Move to the laptop and right click. Here we have a selection: RS232 USB 0, USB 1 or Ethernet adapter. Since we want to connect it through the serial port or RS232 port, we shall select this. On the right of the toolbars you will find a red X. Click on this and the mouse cursor will change to an X. Click on the laptop and this should have to remove the laptop and the cable. Right now the cursor is still in delete mode. To change back to normal mode, press the escape key. We shall now place the laptop back onto the workspace as before. Then reconnect it using a rollover or console cable. From the console port found on the switch to the RS232 or serial port of the laptop. We will now start configuring the switch. Double click on the laptop. Here we can customize the laptop. Click on the desktop tab. This will give us other options. The one we are interested in is the terminal. This is the configuration that we should be using to access the switch. Obviously this has to match the switch that we are programming. In other words, here we have selected 9600 bits through the cable every second. If the device we have connected to can only handle 1200 bits per second, then there will be a communication problem. Leave this at the standard 9600, then click on OK. To be clear, we have connected the laptop to a switch, and using a terminal access application, we are programming the switch. When working with any new operating system, it's always a good idea to find out how you can get help with any commands or navigation. Now that you've connected to the switch, notice at the very end of this page, press return to get started. First notice the prompts. Whenever we first log into the iOS switch or router, we are in the user exec mode, often shown to user mode. This means our movement or the commands we use are very limited. This is similar to the user level access account in Windows, Linux, as opposed to admin or root account. The user exec mode allows us to execute certain commands, but not really make any meaningful changes to the device. We can easily tell when you are in the user mode by looking at the prompt. This indicates user mode. As we raise the privileges, this prompt will change accordingly. To get help, we can use the question mark, and immediately a list of commands that a user can use is displayed. A couple of these commands we may already recognize, such as ping and traceroute. We can also use the question mark for help if we know a partial command but can't quite remember the exact wording. We can see this in the next example if we type in E question mark. Once again, there is no need to press the enter key. This then lists all the commands that start with the letter E. We've already mentioned that we are currently in the user mode. We can move to a more privileged enable mode by using the enable command. Notice how the prompt is changed by the addition of the hash character. This indicates that we are now in the enable mode. To move back, we can use the disable command. Notice how the prompt has now returned to the user mode. Another important thing to note about the iOS commands is that it allows for these to be shortened. An example using EN. And we find ourselves back in the enable mode. Here we will return to the user mode using the shortened command DIS. Here we can see an error message informing us that this command is ambiguous, meaning that DIS could be shortened for more than one command. To find this command, we can use the DIS question mark. And you'll find that DIS could be applied to either disable or disconnect. The shortest command we could use for disable is DISA, the first 4 letters. And this will take us back to the user mode once again. Although shortening the commands can save time whilst you are getting used to the iOS, it is recommended that you use the full commands until you feel confident that you have mastered the basics. The shorthand option is useful, as you may see configuration guides and tutorials using shorthand commands which may look confusing at first, when in fact it is using commands you are already familiar with already. Let's move back to enable mode. Now we use the question mark to view the command in the enable mode. Again, some of these will be self-explanatory, and others we will have come accustomed to. As the number of available commands has increased, there is too many to list on the screen, so we are presented with more. Press the Enter key once and notice this brings up the unforeseen information one line at a time. If we press space once, it will reveal the next page of information. If a command has a particularly large amount of information returned, we can quit the listing once we have located what we need by pressing any other key than Enter, Return or Space. For example, we can get information about all the network interfaces within this device using Show Interfaces. This command shows very detailed information about all interfaces in this device. The above information relates only to one single adapter, so with 26 interfaces in total, this would be a large output of text, much of which we may not need. We can press Enter twice to bring down the information by 2 lines. If we press space, it will display a further page. And if we press any other key, the listing will be aborted and we shall return to the prompt. The question mark can also help us with the syntax and the options which can be used with certain commands. For example, we've just used the command show to view the network interfaces. So to see the syntax, we can use show ? And a list of options for the show command will appear. We can combine this technique as an example show I ? And it will list all the options that begin with the letter I. So far we have seen 2 of the 3 modes we are able to use with the iOS device. The third mode is known as config mode. To get into the config mode, we must first be in the enable mode and then type config. Exec commands used in enable mode tend to be used for gathering information. The commands used in the config mode tend to adjust the configuration of the device. As the course progresses, the purpose of both will become clearer. Finally, save this network configuration as task 01 in a suitable location.